Hi, my name is Aditya, and in this video we will be designing WhatsApp. WhatsApp is a very popular messaging service that allows users to send messages to one another. Before we get started, let's think about some of the use cases of our system. One-to-one messaging. What I mean by this is that we want user A to be able to send messages to user B, and for B to send messages to user A back. This is one use case. We also want three different statuses to be available in our system. What do I mean by this? So we can say sent, delivered, and read. So what I mean by this is that so let's take our example of user A and B here. We want that when user A sends a message to user B, we want our system to be able to tell user A that his message has been sent. So the way WhatsApp does that is by showing user A just one check mark. Delivered is the next step in the process. So delivered would mean that user A has sent a message to user B, but user B just hasn't read it yet. So B would be, B is two check marks if you notice. Read is when user A sends a message, B receives it, and then B reads it. So the reading is two check marks, which are blue. Okay. So we have one-to-one messaging, different statuses of when messages are sent. We can also think about encryption. So this would mean that whenever user A is sending messages to user B and vice versa, those messages are encrypted, which is a feature of WhatsApp as well. We can think about group messages, so group messaging. So users can make groups, add other users to that group, and when a message is sent, that message is sent to all the users within that group. Media meaning you can send pictures, so pics, as well as share videos. So here are 5 use cases we'll talk about. So let's get started with the first one. So we have one-to-one messaging. So let's draw a diagram here. So we have user A here. We can say we have user B here. So user A wants to send user B a message. So one way we can think about this problem is saying that we have servers in the middle. So we'll have, let's say this is server 1. This is server 1. So user A will send a message to server 1. Server 1 will then send the message to user B, and that's a simple way of thinking about this problem. So when user A sends a message to server 1, right? What we can do is have a queuing system. So within server 1, let's say within here, this is our queue, and this server could have a queue of messages that this server wants to send to other people. So a message could have some attributes such as from, to, and the message, right? So user A will send a message to server 1. Server 1 will have this message in its queue, and then when B is also connected to a server, B will receive that message. So how do we know if a user is connected to our system? We haven't discussed that yet. one way to do that would be to have that whenever someone opens a WhatsApp on their phone, or whenever the application is running on their phone, there can be a heartbeat being sent from each user's mobile device to our system, where in memory, for example, we can store something like user, and let's think about, we can say it's a user, we can say user time, and we can store like we can just store user and time. So what this would mean is that if B is also connected to our system, or connected to our system, this information would be available for each server to use, and then by using this information, the server 1 could send the message directly to user B, and then remove that message from server 1. So server 1 won't hold the message. A will send the message to server 1. Server 1 will then send the message to B if B is connected to our system. Connected to our system. So what happens? So we talked about storing user and time. So this would be like, let's say this is user B. Time could just store time as UTC, or perhaps as like Unix. So this could be Unix timestamp, for example. So this is how we can see that B is connected to our system. And this, so the way this would be happening is that A sends a message to server 1, and then A also sends a message to something we can call like a heartbeat. So this could be your heartbeat, and B would also talk to the heartbeat service when B is connected to our system. So by storing this heartbeat B and the timestamp, we can also store the IP address of. We can store